Hello everyone, and welcome to this video on completing the square in one variable. So in this video we're going to be performing something called completing the square on an expression, and the expressions that we're going to be looking at in this video are all going to contain one variable. And when they say complete the square, really what you're going to be doing is creating a perfect square trinomial. So I want to refresh your memory as to what that is and go from there with some examples. All right. So on this first page, we'll talk about completing the square. All right. So before I get into what this actually is, what we're doing here, and I just want to refresh our memory, recall from a prior video a while back on, we were talking about, there were some videos I put up on factoring, and factoring special products and factoring special, special expressions. One of those were called perfect square trinomials. All right, perfect square trinomials. And they looked like one of the following. They looked like some expression a squared plus, and then the middle term 2 times this a again times another expression b, and then finally plus, and then an expression b squared. An expression that looked like this could be factored, be rewritten as a perfect square, or the same factor twice, or something raised to the second power. If you were to factor a squared plus 2ab plus b squared, it would factor to the quantity a plus b to the second power, right? And you can double check this by taking a plus b, multiplying it by a plus b again, and doing all the foiling and combining like terms. You end up with a squared plus 2ab plus b squared. The other one of these perfect square trinomials was very similar looking. You had some things squared, some a squared. Then the middle term, instead of plus 2ab, was minus 2ab. And then the last term the same, plus this b squared. And any expression that looks like this can also be written as a perfect square, can also be written as some expression to the second power. And this expression for this one would be the quantity a minus b. That's the base to a power of 2. And again, you can double check. Take a minus b, multiply by a minus b, do all the distributing, the foiling, and combining like terms, and you'd get a squared minus 2ab plus b squared back. Okay. So keeping that in mind, when we're asked to complete the square, and you're going to see this in my exercises later, my examples later. So when we're asked to complete the square on an expression, what that means, what we're being asked to do, is we're being asked to add something to an expression to make it into one of these perfect squares, or one of these perfect square trinomials. Add something to an expression and make it a perfect square trinomial. Right, so something exactly like one of these two. that can be factored as the same factor twice, written as a perfect square. All right. So, and we're going to be doing this in one variable in this video, right? I mentioned that this is completing the square in one variable. That was the title of the video. So we're going to be looking at expressions in the following form. All right, they'll be quadratic, right? The highest power will be squared, the second power on our variable. So say I have a variable, x, and that's squared, right? So you're going to see a variable squared, and then plus, or minus, right? You see the middle term here, plus or minus. But then plus, and then some middle term with the variable to the first power. So you see how the perfect square trinomials, like if you look at a, you see how the first term starts off with a squared, and then you have a to the first in the middle, times this 2b, right? So what we're going to see is we're going to see x squared plus, and then x to the first in the next term multiplied by some number. Now in a lot of textbooks you're going to see this number written as a lowercase b, right? Off to the side where b is a real number. Right? B is a constant, it's fixed. The only variable here is x. And what you're going to be asked to do is complete the square on this expression, right? And exactly what I'm saying. We're going to add a number to this. We're going to add some last term, a third term, so that we get one of these guys, right? A perfect square trinomial, something that can be factored, to the same factor twice. All right. Something else I'm going to point out that's going to come up in future videos as well. Notice my coefficient on the square term is 1. Right. The coefficient of the square term, right, the x squared is 1. And I want this to happen. All right. Again, in a future video, I'm going to be solving quadratic equations by completing the square. And it's going to be, I'm going to require as one of the steps, we're going to see that we'll want to have the square have a coefficient of 1. Alright, so this is important to put in a bubble here. Alright, so when the coefficient of the square is 1, and then I have another term with x to the first, again, what we're going to be doing is adding something here so that we have a perfect square trinomial. Alright, so let's think back to one of these. Let's think back to this first one here. This first perfect square trinomial. So you see the a is like the x that I have down here, right? A squared, x squared, and then here's x or a again in the second term, right? X here, a there. So this lowercase b and what you see in a lot of textbooks, see the lowercase b down here is acting just like the 2 capital B up here. Okay, so then that means the capital B up there, right, the capital B in my little formula up here for perfect square trinomials is, if I divide by 2 on this equation here, is half of that little b. So when I'm adding that third term, when I want to make this into a perfect square trinomial like one of these guys, we're going to add, right? Notice how both of these have plus at the end. This capital B squared. But what did I just say capital B was? Capital B is half of this, little b, half the coefficient of x to the first. So I'm replacing capital B with, half of little b squared, right? That's exactly like the capital B squared up there. So there's your key. All right, I'm going to put this as like little steps. So off to the side here. So we have completing the square on x squared plus bx, right? X squared plus little bx, 1, right? Step 1. See what this number is. First you're going to take half of b, right? Half of that, whatever the coefficient of x to the first power is, find half of this, right? B divided by 2, or you could also say, half of b, same thing. Half times b, b divided by 2. Then you see what else is done to the little b. First I cut it in half in the parentheses here, and then it gets squared. Right, so then we're going to square this, right, giving us, half of b squared. Then add it to the expression. As I set up here, with plus this half b squared. Now look, if I continue matching this up with my perfect square trinomial up here, remember the x is like the a, so everywhere I see a up here I can replace it with x, and the b is like half of little b, right? The capital B is half of little b, so when we're seeing this x squared plus little b times x plus, half of b to the second power, half of b squared, I can factor it. I can write this as a perfect square, right? This is a perfect square trinomial right now. So it can be expressed as a perfect square. It can be factored to the same factor twice. Remember, a is just the variable x, so I have in parentheses x plus, and then the capital B up here, remember this is half of little b, and then that's being raised to the second power. All right, and this is huge right here, okay? So I start off with an expression like this, say x squared plus 3x, and then I would add, half of 3 squared, giving me a perfect square trinomial. And if it's a perfect square trinomial, it can then be factored as, the same factor twice, or, this quantity x plus half of b squared. Great. All right, so I'm going to keep that up, and let's go into my examples. All right. I only got a couple of them, because like I said, I'm going to be doing this more and more in future videos. I'm going to use this complete the square method to help me solve quadratic equations. All right. So my first example, and in both of these, I have the following instruction. Determine the number that must be added to the expression to make it a perfect square trinomial. In other words, complete the square. All right, that's what you're doing. You're adding something to an expression in order to make it a perfect square trinomial, and then write it as a square, then factor it. Right, like the right side of this, the other side of this equal sign here, this guy. This is the factored form of my perfect square trinomial, this x plus half of b squared. Okay. So I know I've used x so far, but it doesn't matter what the variable is, right? So my example here, I have the variable p, right? And it starts off like I want. See how the lead coefficient is 1, right? The coefficient on the square is 1. We're going to want that. And then I have p squared, and then you have your p to the first term, right? And we'll be able to complete this. We'll be able to add something to this to make a perfect square trinomial, right? To complete the square. So I have p squared plus 14p. So remember the steps, right? Lower this a little bit. Right? Here were those steps up here in the right corner to completing the square. Take the coefficient of p, which is 14. So that's the little b, right? If I talk about the little b, right? Half of that Well, what's half of 14? That's 7. Alright, so that was step 1. Alright, step 1, find half of that coefficient of the variable to the first power. Then step 2, square this, right? So what's that half of b squared? Well, what's 7 squared? That's 7 times 7, that's 49. So this is the number that would need to be added, right? And then step 3 was actually, add it to the expression. So we have p squared, right? We have p squared plus the 14p, and then if I simply add 49 to this, I now have a perfect square trinomial. This expression now with the plus 49 is now a perfect square trinomial, which is exactly what I want to do. I want to form one of these perfect square trinomials when I'm asked to complete the square. Alright, then comes the factoring part. Let me pull this back up. Remember, so I've added the b, I've taken the x squared plus bx, right? The p squared plus 14p. I've added the half b squared, right? The 49. Now we can factor it, right? Now we can write it as a perfect square. And what is p squared plus 14p plus 49 when factored completely? I'm going to set up my quantity, and I know it's going to be something to the second power. And it's very simple. It's just the variable. Right? The first term in here is just the variable, so p. Then the second term is just whatever half of that b was, right? Plus half of b, which is positive 7 here. So there we go. All right. Final result. So I start with p squared plus 14p. Again, you took half of 14, half the coefficient of p, which was 7, squared that, right? 7 times 7, 49. Added 49 to it, giving me a perfect square trinomial, right? An expression with 3 terms that can be factored as the same factor twice, written as a perfect square. And that perfect square is, p plus 7 squared. And you can double check this. Take p plus 7 times p plus 7 and do all the distributing and combining like terms. You will end up with p squared plus 14p plus 49. They are the same. Wonderful. Alright, so let me do that. I have just one more example of completing the square. Alright, so again I'm asked to do the same thing, the same steps. Alright, determine the number that must be added to the expression to make it a perfect square trinomial, right? In other words, complete the square, and then factor it. Alright, so here I have now the variable is not x or p this time, right? This time it's w. I have the variable w. Notice again, I'll point this out one more time. In order to complete the square, my lead coefficient, right, the coefficient of the square term needs to be 1. Okay, so we can complete the square. If it's not 1, we'd have to do something else, but that'll be for a future video. We can complete the square. Alright. So as long as the coefficient on the square is 1, and then I have my term with the w to the first, right? So what we're gonna do is we're gonna take these two terms, right, and add a number to it to make 3 terms that are a perfect square, right? A perfect square trinomial. So what were those steps? So what's that little b, right? The little b is just the coefficient of the first powered term. So that's negative 3 this time. Right, this time it's negative. Alright, then the first step was, find half of this number. Well, half of negative 3 is simply negative 3 divided by 2, right? Leave it as a fraction. Right, that is a simplified fraction. You can't simplify that any further. I guess if you want to write it as a decimal, like negative 1.5, that's fine, but I'm going to leave it as a fraction. All right, then square this, right? Take that half of little b, square it, right? So remember what it means to square something, right? You multiply it by itself. So this is be negative 3 over 2 times negative 3 over 2. And when you multiply fractions, right, you just multiply the numerators, multiply the denominators, and simplify if need be. So it's a negative times a negative, which will be positive. And in the numerator, you have 3 times 3 is 9. Denominator, 2 times 2, 4. So 9 fourths. 9 fourths. This is the number that I will add to these two terms, right, in step 3 here, to create a perfect square trinomial. So let's see what that looks like. So we have w squared minus 3w, and then I'm going to add to this, right, plus that, half of b squared, the positive 9 fourths. All right, and what I have right now is a perfect square trinomial. This expression should be, if I did everything correctly, and I have, all right, this should be a perfect square trinomial. All right, something with 3 terms that can be expressed as a square, right, as an expression to the second power. So let's do that factoring. So again, w squared minus 3w plus 9 fourths, I can rewrite that in factored form as a square, right? It's some factor squared. And the first term in here is just the variable, just w. The second term in here in the set of parentheses under the square is that half of b, right? Half of negative 3, or negative 3 halves, right? The half of b. And there you go, all right? So w squared minus 3w, I added 9 fourths to it, creating an expression with 3 terms that can be written as a perfect square, this quantity w minus 3 halves to the second power. And if you want to double check this, take this expression, take w minus 3 halves, multiply it by w minus 3 halves, and do the foiling, right, the distributing and combining like terms, and you will indeed get back w squared minus 3w plus 9 fourths when it's all simplified. Great. Alright, so that's it for this video. Again, the key to take away from this are the steps in completing the square in one variable. You're going to have an expression that has, we're trying to look at expressions that have one, x squared, one y squared, one w squared, right? 1 as the lead coefficient next to times the square. Then another term with the variable to the first power, and we're gonna, you take half the coefficient of the first power term, then square that number. That's the number that gets added to make 3 terms that can be written as a perfect square. And what's getting squared, the base on the power of 2 is simply the variable for the first term, and then half that coefficient on the first power term, half of that little b for the second. And again, we're going to see in the next video how this is going to be used to help us solve any quadratic equation. All right, great. And as I like to say at the end of these videos, please do the best you can. Try to learn the material on your own before you go looking for help. I have found over the years that people who take the time and effort to learn something on their own, tend to remember that material better and also remember it for longer and are more proud of themselves, boost confidence. So obviously read the material, read through the author's examples, perhaps even try to work out the solutions to some of the author's examples, before you see how the author did it. And then compare your work with the author's and see if you can learn from some mistakes there. of course, do tons of exercises, practice problems. Practice makes progress. Right? The more you do, the better you get. And look up solutions to those, if they're ever made available. And just to check yourself, see how you're doing. And don't give up on a problem or an exercise after the first attempt or two. Don't give up so easily. Very often there are several approaches that'll work for any particular math problem. So if after several attempts at a problem, several different approaches, you're still not getting it, maybe you should go back and read the material again, maybe even a third time, more slowly, more deliberately, take good notes. Because if you've been working on some problems, there's a good chance you now have a better idea as to what the author wants from you, right? What the author is expecting of you. So when you go back and read the material again, or that third time, you'll have a better idea as to what to look out for in the reading. Right? You'll probably catch some things that you didn't catch the first time through, and it'll make working on the problems that much easier. But if after that, if after several attempts at the problems and several read-throughs of the material, you're still not understanding, still not seeing how things are done, it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's loads of them out there. Look for videos online. There's tons of them too, like this one, or plenty of videos out there better than this one, and I assure you they're out there and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think above all, and the hardest thing for anyone is to stay positive about the subject. Believe in yourself and your abilities, even through your struggles and failures and mistakes. If you can stick to it and push through those failures, get past those mistakes, learn how to fix them. Those are the moments when you can learn the most, is moments of struggle and failure and mistake. And you learn more deeply as well. You'll remember that material better, and you'll remember it for longer if it came from a place of error to a place of understanding. And you'll remember it way better and way longer than someone who got it right the first time and just breezed through and never gave it a second thought. They'll forget about it in a week, but you won't, because you struggled and you focused on it and you kept at it until you got it. Alright, so stay persistent, keep practicing, stay positive, and don't give up. And I just know you'll get it. Thank you very much for watching.